Yes.
Yeah. So in our previous session, we have started with a topic called inheritance in system Verilog, where we have seen what is meant by parent class, or parent class or base class, and what is meant by derived class or child class, and how the child class is going to access the properties or the methods of parent class that we have seen in our previous session, right? So in this session, we will discuss about the topic called static properties and static methods. Okay? The topic name is static properties and static methods. So, what is this basically static properties or static methods? Let us consider a class called example, and this class has two properties. Let's say int a and int b. Okay, and let us end this class. And how to create the object for this particular class? So we'll declare the class handle. Let's say example ex underscore h, and using the keyword new we are going to create the object for this particular class handle. Okay, this is how we are going to create the object, right? Up to here it is clear, right? How to create the object for a class handle. I think up to now you must be aware of how to create a handle and how to create a object. Okay, so let's say if we have declared this one handle, let's say this is h1 and comma ex underscore h2. Okay, let's say we have two handles for this class example. Ex underscore h1 and ex underscore h2 are two class handles, okay, which I have declared. And I'm creating object for this two class handles. Ex underscore h1 is equal to new and ex underscore h2 is equal to new. Okay, these are the two objects which I have created for this two class handles. Ex underscore h1 is one object and ex underscore h2 is another object. Okay, now what if I perform ex underscore h1 dot a is equal to 20 and ex underscore h1 dot b is equal to 30, and if I display, let's say dollar display, the value of a is percentage d comma ex underscore h2 dot a, ex underscore h2 dot a. So what is my display statement that will be printed? Any guess, any idea? So what I'm doing basically, I've created two handles ex underscore h1 and ex underscore h2, and I've created objects for this two handles. Ex underscore h1 is equal to new and ex underscore h2 is equal to new. Now what I'm doing, I'm changing the properties. I'm assigning the property values. Ex underscore h1 dot a is equal to 20 and ex underscore h1 dot b is equal to 30. And I'm displaying the value of a is percentage d. What I'm displaying ex underscore h2 dot a. Okay, ex underscore h2 dot a. So can anyone guess the what is the value of what is the display statement that will be printed? That is what is the value of a that will be printed? Any idea? Any guess?
Will be printed. We haven't assigned any value to variable A
Can you
or
repeat your answer once
EX has
again?
to handle.
Can you repeat your answer once again? Your voice was breaking.
I th- I think some garbage value will print because after creating an object for handle H2, we haven't assigned any value to variable A.
Okay. So the default value will be printed since it is a int, right?
Yeah.
So the value of a will be equal to 0. That will be printed. So if we have written ex underscore h1 dot a, the value of a will be equal to 20. That can be printed. Okay. I think up to here it is clear. Now, what if
Yes.
we write ex underscore after the statement? If we write ex underscore h2 dot a is equal to 30 and ex underscore h3 dot b is equal to 40, and if we try to display this same statement, dollar display the value of a is percentage d comma ex dot h2 dot, sorry, ex underscore h2 dot b, ex underscore h2 dot b. So what will be our answer that will be printed? Now let's display the value of a is percentage d, comma ex underscore h2 dot a. So what will be the display statement that will be printed? That is what will be my value of a. Any idea? Any guess?
30.
Yes. So the value of a that will be printed will be equal to 30. Why? Because we are creating two separate objects. Okay, ex underscore h1 is equal to new and ex underscore h2 is equal to new. Okay, so the values, so the modifications which are done to one property item by another object handle will not be reflected inside another object. Okay, that we have discussed in our previous sessions also. Okay, that we have discussed in detail about this modifications in our previous sessions also. But if we perform object assignment, or if we perform object assignment, then the values which are modified by one object handle will be reflected inside another object handle, and that will be overcome by our shallow copy that also we have discussed in our previous sessions. Okay, so for uh, so in this today's session, what we are doing basically, we are creating two objects and we are modifying the values of the same property with the help of two objects. Okay, we are modifying the value a with one object handle, but it is not reflected inside another object handle. That means each object handle has its own copy. So ex underscore h1 is having its own copy of a and b, and ex underscore h2 is having its own copy of a and b. Right? Up to here, is it clear? I hope it is clear. Right?
Yes.
Now,
Yeah.
yeah. Now, so this is about a normal class example. Okay, but if we declare any property as static, okay, static int a and static int b. So if you have declared any class, any property as static, okay, so if you have declared any property as static, then what happens is, if we may create n number of n number of handles for this particular class. So in this example, we have created two handles and we are accessing the particular property. So separate copy has been created in the each object, but since we are creating the property as a static, so the same variable will be shared across all the objects has been created. So since the a has been created, a has been declared as a static variable, so the same property will be shared across ex underscore h1 and ex underscore h2. So this same property, there will be no separate local copy will be created for this a in the ex underscore h1 and ex underscore h2. Since it has been declared as static, so it will be shared across this two object handles ex underscore h1 and ex underscore h2. Okay, so if you have modified the value of ex underscore h1, let's say dot a is equal to 30, and another step, if you perform ex underscore h1 dot a is equal to 40, so this 30 will be overridden by 40. Okay, sorry, h2 dot a is equal to 40, so this 30 will be overridden by 40, and in the two display statements you will get the statement as 40 comma 40. Is it clear? Is it clear?
I think your screen got stuck in between. So
uh,
yeah, now it is
Now it's
visible.
visible.
Yeah.
Yeah. So since we have declared a as a static property, so what happens, instead of a being created locally in the two objects, like in the previous example, a will be shared across the two objects. A will be shared between the two objects ex underscore h1 and ex underscore h2. So any changes which are made to this a property a will be modified in the uh, next created object also. So if we have written ex underscore h1 dot a is equal to 30 and ex underscore h2 dot a is equal to 40, so this 30 will be replaced by 40, and in the two display statements you will get the display statement like a is equal to a is equal to 40 and a is equal to 40. Is it clear? Since the a is shared with the two objects that has been created, because a is declared as a static variable. Is it clear?
Yes.
Yeah. So in this example, we haven't done any object assignment or anything. We have created two separate objects. Okay, we have created two separate objects. Ex underscore h1 is equal to new and ex underscore h2 is equal to new. And what we were expecting, that the local copy will be created for the both objects. Okay, the local copy of a will be created for the both objects ex underscore h1 and ex underscore h2. But it is not happening because the variable a has been declared as a static property. Okay, it has been declared as a static property, so it will be shared across all the created objects. It can be any number of objects and that are created for this particular class, that will be shared, this property will be shared across all the objects. So any modifications which are done to this particular property by one object handle will be reflected into another object handle. Okay, so this is about static properties in SystemVerilog. Okay, now, so the use cases of this static property will be, if we want to implement any, let's say, counter type logic, so we can declare any variable as static and we can use that variable to implementing the counter type logics. So basically for counting, so without not missing the count, we can use that particular property. Okay, we will see one example in our next session how to declare this and how we are using it as a counter type. Okay, so yeah, now let us start with the discussion of static methods. I hope the static properties is clear, right?
Yes.
Now we'll discuss what is meant by static methods. And one more thing, there is no need to create the object. So static properties can be accessed either through the class name or any instance, but there is no need to create the object for this particular static, for accessing the static property. That we will discuss in our next session when we are coding. Okay, when we are seeing the code, that I will tell you how to access the static properties without creating any object. Okay, I will show you that. Now let us discuss what is meant by static methods. So just like static variables, we can create static methods. So the static methods cannot access non-static variables directly. Okay, so this static methods cannot have any non-static variables directly, since they don't belong to any particular instance. So static functions are just like the static methods. So let's say if we have static function int add, let's say int a and int b. Okay, return a plus b. So this is a static function. So this is a static function. I think we have already discussed this static methods in our previous sessions, right? Do you remember anything? So it will basically act as a static method. So any function call will, so basically for every function call there will be the same variable which will be used for every function call. This yeah, this actually we have discussed in our previous sessions only. So if you haven't watched this, please revisit them. We have discussed this static methods previously in our session. Okay, so let us see one more thing. Let us say if we have declared any static property, static A, and if we have declared the same function, function int add, or we can say increment, and a plus plus end function. So normally, this function, if it is declared in a class, this function, if it is declared in a class, and uh, let's say I've declared one more variable as int b, okay, b plus plus, okay. So if we call this function for the first time, what is the value of a and what is the value of b? Any answer? So if we call this function incr, what will be the value of a and what will be the value of b? So the value of a will be equal to, so it is static int a int b. So the initial value of a will be equal to 0. So it will be equal to 1, a will be equal to 1 and b will be equal to 1. Okay. And if we call this function for the second time, then as the property is declared as a static, so the same variable will be used for the second function call. So the same variable will be used for the second function call, so the value of a will be equal to 2, but a different local copy will be created for the second function call, so that's why the value of b will be equal to 1. Okay, since it is not declared as a static variable, so the same variable will not be used, so a local copy will be created for the second function call, so the value of b will be equal to 1. And if we call the function for the third time, then the value of a will be equal to 3 and the value of b will be equal to 1 itself. So this is how the static properties works inside a normal function also. Okay. And if we declared a function as static, then the variables declared inside those or the properties which we have declared inside those method will also act like a static properties, and it starts working in the same manner that we have discussed in our previous sessions only when we were discussing static methods. Okay. Yeah. So that's all about the static properties and static methods in SystemVerilog. So in next session, we will start with a topic called polymorphism in SystemVerilog. Okay. So yeah, so that's all for this session. So if you're having any doubts or queries, you can ask me, or else we can end this session. Thank you.